Hello, and welcome back to Factorio. My name is Abuck Nasty. Today, what we're going to go through is a deep dive into my military science build that I showcased in the Formula SPM video. The goals today are to look through this build, and one of the goals and objectives that I have for this video is I figured it would be nice to walk through some of the design philosophies, some design processes that I tend to do when I'm looking through this, to keep it relatively simple so that if you're new to megabasing or you're just new to endgame designs in Space Age and want to get a little bit more familiar with what to start for, where to go to understand how to build something like you're seeing here, I figured we'd do a deep dive and go into that today. There's a couple things that I know could be better about this design. So first off, let's go through this. These are some of the main building blocks that we have. This was the design for stacking and using furnaces to create stone, and using the rocket silos as a medium instead of belts. I want to test out today if that makes sense. Let's try a version that is belts instead of rocket silos and doing some UPS testing around that. I'd also like to look at, there's some basic building blocks that I have in the modules for uncommon. So there's the 240 per second for iron and copper that I was looking at here. The question that I'm going to kind of pose is, I know there's a couple things that could be optimized. One, I had a suggestion that was posted in a comment that was saying that there could be direct insertion from a furnace directly into one of these assembly machines crafting grenades. I think that's a good idea. I want to try that out. I would also like to look into a little bit the copper production that's here. This is pretty overkill. I use one of those basic modules that I showed before to make 240 per second, but really looking at the consumption rate here, this is only 30. So I think we can get away with, ideally, direct insertion from one of these furnaces to go directly into each of these assembly machines here, crafting ammo. So, and the same thing for steel. It would be nice if we could feed it with enough iron directly from raw inputs here to make enough to power this. And I think that's possible as well. So we're going to try that. We're going to try to go through that, and I'm going to start from scratch for each of them, walk through them a little bit to explain my design processes, and I'll see you there. I'm going to be using this as our guide as we go through the different items. And we're going to start where I normally start, which is not at the raw inputs. I've specified all the items that we're going to need here. I will record a separate video on the upcycling process specifically. So if you want to see that, you can look at the Formula SPM video. There is I'll post a link in the description where you can see that and see a little bit on how you can do some upcycling techniques. And if you want to know more about that. For what we're going to do is, where I normally start is I start off at the foundation of what is the end product that I want to create. So I know that that is going to be here. I want to make this science. Well, okay, cool. This is going to require uncommon walls, uncommon grenades, and uncommon piercing round magazines. So one item that I will normally do is I will say, all right, is there a candidate for direct insertion that would make sense? And what we're going to do is we're going to take the existing design that I have, because I figured out some of these ratios already, so I won't go into that right away. But we're going to take some of these at face values and build upon that. So one of the reasons I decided here to do direct insertions of grenades is that it just works out 1-to-1. You can have one machine making perfectly the amount of grenades that you need, and you have a slight surplus. So what I mean by that, I use Rate Calculator as a mod to really easily give me stats on the production for different buildings and what their positives are. So in this case, this is making almost 1 extra per second. So That's enough where instead of having one inserter to drop onto a belt and then another inserter to pick up from a belt, what we're going to do is just have this directly feeding in. And that makes sense. A bad candidate for doing that would be directly inserting as an alternative. We could be doing this. But this already produces significantly more without even any beacons than without any beacons that this could actually consume. So it is, looking at this, is 0.12 that this needs, just without any speed modules. And this is making 6.25. So the moment that I add a single beacon to this build here, this is going to be a wild surplus, so 6 times as much. So one of these can feed 6 of these buildings, and we're going to add more beacons and go into that. So this seems like a bad candidate for that. We could also do walls, is the other alternative. But the rate that this makes is 21.8 walls per second, and well, this only needs 4, so that's still not a good solution for direct insertion. So because these are so close already, and if we can add more beacons to fully prove that out here. Control 8 or pressing H is for flipping. I'll do that a lot in this video. You can see that the numbers are slowly approaching a point where they both are equal. So this one seems like a good candidate for direct insertion. So we're going to start with that fundamental piece, and we're going to work backwards from there. So for convenience, I've added here all the items that we're going to be consuming as inputs on belts. We know that we're going to be wanting to smelt iron ore in a furnace. That's going to be the one major change here for this design, is we're going to be wanting to directly insert from the furnace into the assembly machine for the grenades. So let's start where I normally start, which is the output of the item that I actually want to make, which is going to be this for the military science. So in theory, we can fit around this building a total of 12 beacons here. And you can see that by the indicator on the right-hand side there saying that it's 12. So while we could be doing that, what I know that we can't do is we can't insert and fit a building anywhere around here, so we're gonna have to make a compromise for this. So let's go ahead and delete these two, and we're gonna shove these a little bit closer just to give us some more space. So I'm gonna go ahead and put this grenade here, and we're gonna have now a stack inserter to bring those items in and a stack inserter to bring it out. So I'm going to bring here a belt for the output, and we'll delete that. So I'm going to talk about being tileable. That just means that I can copy and paste this design, and all the inputs and outputs are all going to line up. So the other thing that we already previously did, which I really like from the other design, is we need 2 more inputs here. We're going to need piercing rounds and walls, and uncommon walls. So let's go ahead and include those. You can press Q on any item in the game, and if you're not in the editor mode, it will show a ghost icon for it. You have to enable a setting for that, but it's just to enable ghosts if the item is not in your inventory, but very useful if you're in remote view and you want to set values in constant combinator and don't want to mess around with finding them. The only one that doesn't work is walls, at least not as easily, because it's going to try to place a wall, so we're going to manually select that one for here. So like buildable objects is not a thing, but everything else will work that way. So these are going to be the 2 other items that we're going to want as an input. Why am I using a constant combinator? It plays really nicely with the infinity loader from the editor extensions mod that I'm using, because I can shift right click and shift left click, and then I get that item fully stacked. This changes based on your research level that you have. I have modified this to be exactly like my 4 million SPM base. So that's the exact same research levels, and so I'm going to be assuming that, and this is going to be for ultra late game build. So we're going to keep all of those settings around. So one of the things that I liked about the previous design was we had this kind of weaving belt here because you need 3 inputs effectively for this design. We're going to mirror this again for tileability, and we're going to delete that. And then what I'm going to do is we're going to have this input, and we're going to grab one of these infinity loaders so we can already simulate this, and then shift right click, shift left click. So we're going to need an inserter to pull items in, And now we've satisfied already 2 of those conditions. We're going to figure this part out separately like we said, but let's go start with this here. And I'm going to move this slightly down so I can copy this blueprint later and it will make sense. So next, what we're going to need is some way to get coal into this and also have the ability to have a furnace next to it for direct insertion. So we could line it up here. We can try this. I'm thinking it's probably going to be better if we offset it up here a little bit more. That still gives us the ability to get some more beacons around here, which is good. And where I'm thinking to go with this is, let's go ahead and we're going to have a belt that's going to come inbound. This is going to be this right here. So let's go ahead and do that. And we'll bring this in so we can fit more beacons in. So let's do that. Bring that in. Bring some more beacons in. Let's see if we need them. So this is going to then be a input here for the iron, and we'll go ahead and start putting that in. So this is making already 37 per second, and this is requiring 41. So we're going to need a slightly different placement of the beacons and the furnace itself in order to make enough for it to produce this. However, if you look at this, we only really need 6.2 or so per second, which we're seeing right here, or 6.3, just rounding. And this is making 8.3, so this is already a positive offset of significantly more than it needs. So to get this right here, and I'm going to look at this, although this is at a deficit, really we're only going to need 6.3 of these, and to kind of simulate that, let's say 0.78, yeah, that's good enough. So you really need like 32 or so per second, and this is making 37. So this is actually plenty already. Even though this is only 6 beacons, this is enough to satisfy what we're going to need here. I think that's convenient because that means we can also run a second input, which is going to be here. We're going to need some coal as an input. So let's bring that up. What I'm thinking to do here is maybe something like this, and then back out. Right there again, out, out. And then that will be enough for us to satisfy this. So I'm going to just, for convenience and visualization purposes, make these indicator like this here. And we're going to filter also the item that's getting inserted. So, okay. So now we have already set up here something that's going to be all creating a surplus of iron, a surplus of grenades, a surplus of grenades, and enough to satisfy the military science pack. So, okay. So I kind of like this. I'm going to run this just to see if this is working. So let's go ahead and include here some coal to come in. And we're seeing that the science is running. Perfect. Bring that up. Let's have it output. So one thing that I like to do for my builds is I have a little inactive color. You'll see that a couple times. It's just this little pink color that's here. And we're going to put these here. So one of the things I'm going to do, and I just like this for visualization purposes, and I've already preset this up before. I set a W signal for when the recipe is finished and when it's working. And if either one of these are the case, so let's say it stops running completely here, then the recipe won't be finished and it won't be working anymore, so then there will be no signal, so then pink means it's sleeping. So I'm going to go ahead and do that. I've talked about kind of not clocking inserters, but conditionally outputting them. I'm not going to go super into the weeds on what I'm doing there. I'm going to simply just do it on one thing for this. I'm reading here the contents and including and crafting the items that are in here. And so I'm going to have the one thing I don't like, and we'll show this with this overlay, I don't like that the inserter is actively pulling items 4 at a time from the assembly machine. So what I'm going to do is I'm going to limit that, and I'm going to say I only want you to do this when it's greater than or equal to 16. So that now we just have one swing. That seems like a good improvement to make with a little bit of an overhead on having the circuit connected to it. Thought I had to sneeze. So with this now here, this is going to be now only putting out once this item has 16. And the reason what I'm going to do here as well is I'm going to hold the hand contents. There is a case where this can get stuck, not necessarily on military science because the stack size is high enough, but there's a case where the bulk inserter or the stack inserter and the assembly machine, it will stop because it thinks that there's enough to satisfy the 16 that are in this, but this has only picked up 4, but then the condition is not satisfied because this only has 12 inside of it because it's only reading from here. By reading it also from what is the current stack inserter holding, then it will consistently always will run even in that deadlock scenario that exists. So what I mean by deadlock, that means that it's a concept that an item is waiting for this condition to be satisfied, and it's waiting for this to be greater than 16, but this item by the game code is waiting that the stack inserter has picked up all the previous 16 items that were in the assembly machine. So to avoid that deadlock, we read both, and then we're completely fine. So why do I doing this? I find this to be a little bit more UPS optimal, less swings, less active time is a good thing, and so we're gonna go next now into grenades here. So just adding a filter for that. Let's add the same little start-stop signal here. I've already pre-done the work of adding them, so now we have this little indicator. I'm going to copy this light here. I'd like to have it coming out of here as well. This is more of a symmetry thing. I don't necessarily like... I like that these lights are lined up here all the way across. What I don't like necessarily is that the amount of distance that this is away from it, so I'm going to try to slightly rework this. What I'm going to do is I'm going to place the light over here and move this inserter down here, and then I'm going to move this down. And it doesn't impact or touch more beacons for this build, and that's okay. But then, yeah, just for me, this satisfies that all the lights are in a row, and it's easier. I enjoy symmetry, so it's a thing there for that. And otherwise, I think this looks good. We've got everything getting inserted, and this is constantly running. This light's never pink, so I think this is a good module. So I'm going to go ahead and copy this. I'm going to press Shift to create a module for it, and then I'm going to go give it a name and add it to my blueprint book. So I've gone ahead here and renamed it. This has got all the components that are in it, and I have just this little requester item slot I'm using as a module indicator. And go ahead and create this blueprint. And I'm going to save this now in my modules section. So we're going to put this in here, and we're going to work off of this section here. We'll have this temporarily until we have the final design, and then we will we'll ultimately eventually wind up cleaning these up. So the next step of this, now that we have this module, I've moved it now into the science folder for where we previously had the blade that we showed in the very beginning. We're going to go now into, let's go and create this so that it's going to create a full 240 per second. So we have this concept here, so let's go and move this over. I know that this is going to produce here a total of 50 per second, so I need 120 per side to fully saturate a lane that's fully stacked. So let's go until we get to 120, so that looks like 5, so let's copy this 5 times. So we got 1, 2, 3, 4, 5. Now let's go look at that again with rate calculator and see what we have here. So this is having, looks like This is making 252. That's slightly over the amount that we need. So if we do 0.95 or so, that's close enough. So that means really the numbers here are going to be, this is 120, 60, and 60 of the items. That's perfect. We already have a belt where we don't even need to stack these technically, but I'm probably going to do it anyway. So I'm just going to stack every item that's on here because we can, and it's nicer because then these have less swings that they need to do picking up items from the belt, and there's less gaps. So we're going to oversaturate these belts, so we're going to feed them with 120 per side instead, but we're not going to produce that. We're just going to produce the 60 that we actually need. For the walls, on the other hand, that's also going to come along here. That is going to be consuming the full 120 going all the way to the top, so that should be fine as well. On the other half will just be the piercing ground, which is going to be 60. So since this is at a slight surplus, let's go ahead and include from this previous module build here the straight inputs that we're going to need. And let's let this run. I'm going to go and delete that. Now this is all running, all the items are coming through. And okay, I'm going to delete at the top of this. I don't need this output anymore. That's probably fine, and we can probably even just delete those two as well. We don't need them. So that cleans up the inputs. We can do the same thing here for the iron ore that's coming up here. We can just delete that. And then otherwise, some other items that I think I want to do is I don't need this just the number of belts here. So I'm going to redesign this. We're going to have just those inputs, and then when I'm done, I will be back. Okay, so we're here now. We've made the optimization of having just undergrounds feeding all the way across because there's enough distance to cover this gap. And at this point now, the next thing that I need to do here is I'm going to have to design at the top how these are going to merge, but also a thing that I'm going to point out here is one belt of coal is not going to be enough. We almost need 2 belts worth, so we almost like 480 would be 2 belts worth. Now I know that we don't need this amount technically because we really only need 31. Like, we know this is oversaturating, so this is 41 that this is making, so that's gonna be kind of close enough. Let's do this. Actually, that's perfect. So it's gonna need about 300-ish coal, so we're gonna need to have then 2 belts going along this. So the first items that are going to need them is these 3. This is not going to be consuming at 240, like I said. It's going to be, a little bit less. So really, this is about a full lane's worth. So what we'll do is after this point, we're going to start merging it and adding a second belt in. So all I'm going to do is I'm going to add another one of these inputs, and then conveniently here, there's a location right next to it where we can add a couple more. Now we'll have to design this a little bit differently. I'm going to want to merge this in, and then input priority for me is going to be all the items on the right, and then the output priority is going to be on the right. That way it's always consuming what's on this side. I think instead, let's do input priority on the left, because this is going to be an unused lane the entire time. So then that way there's going to be back pressure here between these 2 items. That's going to be close. Yeah, again, to look at this here, it's going to be about a half lane that these need. And then that same metric, because this should be here, that's going to be just over a full lane. So that allows these 3 to constantly consume the full amount, and then this just gives the extra half lane that it's going to need. So that should be fine. So let's go ahead and Control-C copy this, press H to flip it. And then I'm going to try to get this in here. I'm going to press Control-Shift to force place the item. You can see the Angry Ghost icon there. And there we go. So now all we need is to modify that input. That should be enough, and we'll test that out here in a second. I'm going to design now a merger. Now, I'm going to recheck this with the... now that we have a couple less beacons. This is still making 240 per second, so that's perfectly fine. Can add one more beacon in here, that's not going to hurt anything. what you're going to notice, and I'm going to run this without adding any extra inserters first, just so we can watch this. And to make it really easy to visually see this, I'm going to make its turn. And I need to rotate it. All right, so now this is running. We're going to let the science kick up. So I'm going to start going game speed, let's say 10. And you're starting to notice that there's some gaps here in the belt. Even though we know guaranteed that we should have enough to saturate the military science here, so 240, we're seeing that this is stopping a lot of times, this particular machine. Like there's 32 items in here, but there's still somehow gaps up there. It happens because the inserters, when they're trying to drop items, they create gaps when it perfectly lines up that when an inserter has finished dropping an item and is going to back to swing and grab another one, they're not going to be able to fully continue to run, and it's just timing wise, it's going to happen where they're not fully aligned. So to get around this, what you can do, you can add another inserter right here at the end as a cap. This will fill the belt fully all the time, and it is a way to simplify this problem and allow this to constantly be full, because you always have one extra one on demand ready to fill in the extra gap whenever this one's picking it up. What I personally like to do though is I like to add these like this at the end of the designs. I did this in the previous one so I could keep it here. This allows now the inserters to constantly be outputting items onto the belt without ever needing to, with having a little bit of a buffer for them. So that buffer effectively is going to allow this to constantly be pulling out of these the assembly machines. Let's go ahead and try it with just this buffer mechanism here at the end. What this is actually allowing us to do is we're using the length of this belt now to close that gap and allowing these to constantly still be swinging. So we're actually saving now one extra inserter, and we don't need that anymore on this design. So instead of now having the two inserters that we used to have, just making this design here is enough to allow them to constantly still be outputting. So to close this off, we could still have a couple more beacons here just to minimize the runtime on these, even though it's overproducing, because we're still oversupplying the amount that's on here, right? 249, and we only need 240. But that's fine. That means that these buildings will run a little bit faster during those ticks and will stop. Don't know if that's exactly better for UPS, but that is my assumption, so we're going to take that. So now we've got a pretty good output module for the science. We'll clean this up a little bit here. We don't necessarily need these belts. And one last thing I'm going to do is I'm going to use the same output philosophy that we had on the right and clean that up, and then I will create a blueprint of this afterwards. So I've gone and cleaned up the belt so that we're minimizing just the number of belts that we actually have to ship to Novice to create this. And now we're mainly just using undergrounds here for everything. And finally, what I'm going to do is we're going to need some power. I have here on the surface a global electric network checked off on my demo world or my test world, just so that we don't have the annoying lights. But what I'm going to do is, I know that we are going to anyway now going to actually use this one day, so let's add some power. So what I'm thinking to do is I'm going to try to bring this in as close as I can and still affect all the power just to make it easier to connect. I could put it here, but then we're not going to be able to, I think, fully reach when we get into this scenario down here. Like this to here, there's not going to be a wire that's attaching. So I'm going to put this here, and we're going to move this down, and let's try every other. It's perfect, and then we'll match that on the other side, every other. Okay. This looks like a good module. If I look at power, just by holding Q here and holding one of these in my inventory, everything is covered power-wise. Great. So I'm going to copy this, and I'm going to call that a module. So that is going to be the head module for the tail module for the output. Now we've renamed this. Of calling this military science pack. It's an output and it's the item request slot, so that's our module symbol. So this is a tail for the output here, and we've saved that now and include that in our blueprint book. So now we've satisfied what we're going to need in terms of still honoring the raw inputs that we're going to need. We need to now go and work on figuring out potentially testing out the current wall design, and let's add potentially a new one, like we said, that was just belt driven. And we're also going to need the piercing rounds and some new concepts that are there. So we're going to work on that part next. The next thing we're going to tackle is getting into making piercing round magazines. So where the previous build left off is we had here the main processing using those modules that we talked about before. This is overkill. We don't need this amount of copper coming into here. So having this a number of furnaces, really only this one's ever active, so I'm thinking that we could reduce that already. I'd like to ultimately, the goal would be, let's directly insert this into the assembly machine, making the piercing rounds, and also have the steel directly inserting into there. So with that being said, let's go back to the base components that we're going to need. So this is going to be the setup. We're also going to need one of these as well to directly insert into electric furnace. But then I know that for this build, where our original module was over here, we know that we're going to need 30 per second that we need to satisfy. So let's design something that does that. So just looking at some simple things here, and I already know this from the previous design. If we add a beacon like this with all speed modules, that already is producing close to the amount that we need, and if we add a total of 3, that gets us to 30. So this is all we need. So we need to satisfy this amount of steel, this amount of copper, and we're going to need, and the main amount of, we need a lot of iron, so almost a full lane of iron plates. However, this is at a gross positive amount, so really the amount that we need to satisfy in order to hit this number is we really need to be making about 30 firearm magazines. So this is 52, so let's go for 7, 6, 5, something like that. So we're gonna need somewhere in the ballpark of just slightly more than half a lane, but a little bit more than that. So then if that's the case, that we need about 30 of these, so then, man, that's really close. That's exactly half a lane of iron plates, so we could get away with that. I'd rather slightly overproduce and saturate with back pressure the belts, so we'll go for that. We'll go slightly higher than 120, but that should be enough to cover the 30 that each of these will need. And yeah, so that's good. And we'd like it to ultimately be overproducing, because over here, again, the belts, we want them to back up and have back pressure so there's no gap, so slightly overproducing should be just fine. So again, we're using very minimal amounts of items here. So let's take this concept. I'm going to want to kind of design something so that ultimately in the end I can flip this. That's what my goal would be here. So let's start with the furnace that's going to be inserting steel directly into this. So let's start with that. We'll have some items here, and let me go back into the editor, and we know this is going to be steel. So that's going to be input. I'm using speed modules here because we already have 300% productivity. This is going to assume that. So if you have less than that, then you need to put productivity modules in there, but that will reduce the speed. So we're going to go ahead and do this, and then I know I'm going to need another inserter, or another one that's going to insert here. Let's just symmetry-wise, that usually pays off in the end. We're going to need something that is going to put firearm, or not firearm, but the iron plates into there. So let's do that. So then we're going to, just to test this off, to give some numbers. And I did that wrong. I need some ore. And then let's grab some of these. There we go. So now, I don't think this is going to be enough, so we're going to have to add some beacons, so let's go ahead and just do that. I'm going to try to fit these in as close as possible. So let's do this. I need to have this, so this doesn't have to be symmetrical. So let's go with then, let's move this one down, that's fine. And then again, we're going to input that in here, and we're going to say this in there. So look at this now, ratio-wise. Okay, we're at a slight deficit on the iron plates, but we are good on steel. So is this overproducing? And so we can just easily slap another one of these in here, and that's making an extra 9 per second. And I don't think that we're going to need... Oh, there's a very important thing. I need to put... Or people yell at me over that. Productivity in here. Oh, that makes a huge difference. 15 versus... There we go. That's what I need. So now, oh, that is just about as close as you can get to being perfectly ratioed. And it's overproducing, so that's fine. So this is perfectly good. So let's get a belt in here. So we'll do that. Just keep it simple. So do this. I am personally going to clock this. This is an unnecessary step. But I am going to do this as I'm still trying to test out this concept of limiting how often inserters are reading from a belt and swinging. So now with this setup here, what I'm going to need now is a place to bring in iron here, so that there won't be enough space for that here, so I'm going to move this up ever so slightly. We know that the ratios are still working out, all those beacons are still hitting it. So I'm gonna probably want to bring in from here, bring it in a little bit more central. And then all the way down, and then do inputs, so. We said before that this is overproducing, and it needs 120. So having 2 of these should be enough to pull it in. If we need another one, we can tack it on here, but now we have enough space for that, so that's perfect. So output. We're gonna need some firearm magazines here for this. So just, again, filters are unnecessary, but I'm putting them in anyway just for visualization purposes. And then we're going to need some output here. I don't care, this could even just go here. That's not bad. I'm not going to fit another building in here, so that's a decent thought. So then that'll be my output. I'm going to need a building, like we talked about over here, to make copper. There's nothing special about this building, I'm just copying it for reference. And then let's try that. So we could do this, and then copy this and flip it up on the top. And let's just see what the ratios look like for that. So let's just bring this in here. And I'm going to need to bring in here uncommon ore. This is making 16 per second. This is 17, so not quite enough. So we're going to need then potentially another beacon for this. 16.2 to 17. So I'm going to add in another beacon then for this. And let's move that here and here. So then, yeah, that's now at a surplus. The iron is at a slight deficit, so we can always just add more beacons in for that. That's not an issue. So we could do something like this will hit both of them. And then if I look at this now, or rather on the bottom here is more interesting. All right, now we're back to that same ratio we had before. Great. All right. So with this out of the way, I can't move it any further up or down. That's fine. So What we can still do is we can even make this more compact, so we could have this kind of coming up here and down like this, so then this could just filter in like this here, and then we can bring this in here, so then that's even an extra layer of compaction, and we could put even more beacons on the side if we wanted to. So then this looks good. And then yeah, this is just going to be the output for this. So this is going to assume that we have, let's try with just one half belt and see what that looks like. And we're also going to need iron ore input here, which we could feed from whatever's making this. So we will say this here. We'll just saturate it for now. And then let's run this. That looks good. Let's delete and recreate it. So this one's constantly getting... Okay, so we're not able to feed enough iron plates into here. So let's add a second lane and see if that helps, because I can technically then pull a little bit faster off. Okay, I have turned off now any other machines that were making this, so we can watch this directly on the graph. So we're making about 2.2K per minute, and that was the estimate that this could be making. So looks like now this is in a good spot. We'll let this run for a little bit just to make sure that we're constantly sustaining that, and 2.2K is anyway over the amount. This is making 36. This is already enough. So that's perfect. So what we can do now is we can take this and we could flip this so that they're both on each side. I still need to figure out how to create the amount that we need here, so it's definitely over 120 to make the ammo that we need, or just slightly over, so although we don't need it. I'm going to take this existing module that I have here, and we're going to slightly rework it, I'm thinking. I don't think I quite need this amount, so I'm going to try to get away with having half of these here. So let's cut this, move this up, and that has more beacons affecting them here in the middle. And then I can bring this up just to have a constant input. And then what we will do, by the way, this is a kind of a neat trick. What you can do here is whenever you have two buildings next to each other, this can also be these assembly machines. You put them like this, you can have one thing inputting like this. So we'll flip this to demonstrate it. That's how this design works. You have your raw input here, so we'll bring that in. And then your output can be like this here on the sides, feeding in. And that works because they happen to exactly line up with the tiny little gap that's here on the side of the Turbo Underground belt, and well, any belt for that matter, and then this will come out. This also has a nice benefit of not interacting with the same lane where the materials are being produced off of. So that is a nice thing as well. So then what we'll do here is, I'm going to just delete that. So let's try this out for a second. I'm going to have just this as the raw inputs here. We're not going to need this amount, but because I think this will only be consuming at just almost half a belt, so we're not going to need 480 input for this. So this is now, this should be producing 191, which you know is already almost the full amount, and this is a full saturation, so that looks pretty decent to me. Let's kill that, and then let's remove some of these inputs that are here, and let's do this. Move this around, so I'm going to need that iron to come up like that. And the nice thing about these beacons being here is we can probably get away with just shoving this right up. Yeah, almost completely. Oh, this is convenient. This lines up perfect. So then, to minimize belts, we could bring this all the way down here. And then just to promote some symmetry, we can do that. That way we can add more beacons. Cool. So we're gonna need now, again, an input like we had over here. This is making 27, this needs 15, this is making 22. Yep, we are over capacity. Fantastic. The only last thing I'm going to do, because this should stack up pretty high, is I'm going to add that same logic conditions that we had before to only enable when this is greater than 16. And this should stack well enough, high enough, but we're just going to add that for safety measures. So then they only swing occasionally. So that should help a little bit with the active time. We could add a couple more of those conditions. I'm going to not go overboard with this right now. I'm going to add them on the ones specifically today that interact with belts. So we're going to say this is less than 16. Do the same thing over here. I'm doing this again just as I'm still testing out that this is a better UPS method. And go from there. So I think we have this module. We can go ahead and copy this over so that we have two of them, because we're going to need two halves for either side of the final inputs here. And I think that's set for creating a new module for creating ammo production. So off camera, I came up with a new design that is belt driven. The concept here is the same as the previous one. We are, because we can add a couple more beacons around them, we can technically get away with 7 instead of 10. So already I'm thinking that this is going to be a better design. Just looking at the difference here, there's 55 stack inserters, and the difference over here is this is 50. So this is technically still less inserters than the last one. The main thing that I'd like to test, and so I will create two fully configured and buildings, or two full blades, one that has this assembly and one that has this one. What I'm still curious about testing wise is if there's any noticeable improvement of, instead of going the silo chain of moving materials forward, if still using belts and interacting with belts is going to be worse or better. But there are less overall inserters in this build, which is good. So we're going to try both out and we'll come from there. At this point we have reworked now, so to touch base on this, we reworked the ammo production. We already have grenades, and we already have now the wall, so now it's just time to combine them all and hook them up all together and form them up in a way that kind of makes sense. Alright, so we're back now, and I've turned off Global Electric Networks and just provided a power interface here for this so you can go and look at it. We now have a new blade that has the raw inputs now coming from the top here. We have one extra for the iron on the bottom. This is the same on for this build. This one's the one using the rocket silo inserter, and it is now feeding this system here. It's just filling up now, and this seems to be constantly producing, and we're good in this sense now. So this is now similar to the last build with the core, but now is using the bottom base that we redesigned in this session and using the new output top portion. So comparing this now up here with the new inner module that we have, this is also running and is perfectly supplying this top as well. these designs, what I'm doing here, and the reason I have the roboports and the location specifically that they are, is I want to ensure that there is enough coverage to build the whole thing, but I don't need more roboports than this because there's no logistic requests going on. So this just needs enough to daisy chain and have enough construction robots to build the whole thing and then get out of there. So same thing over here. We have now enough coverage to assemble and manufacture everything that's on here, but we don't need any more roboports on this. I guess we could technically fit these here, and that's going to be enough symmetry-wise. Cool. So what do these look like compared to the original design? Well, the original design is here. So we'll put this in the middle for comparison. So one thing that we've done is we've drastically reduced the length compared to the original two designs. So that's already a positive. The width has also been shrunk in both cases. So already net-wise, this seems to be a more compact design, which I like. So the question is, the rocket silo build is slightly more compact compared to the other one, but ultimately at the end of the day, what really matters is how much UPS do these draw. So for this next test, the goal is to grab 16 of these bad boys. We'll run them at 100x speed, and we'll take some measurements before and after. So this is going to be a test with the old blade design, the first version, so V1. We are running this right now at 1x speed, so we're going to see now. I just kicked it on, so let's go look at the production output. So we're at 230K. That makes sense. This is twice the capacity of what I'm using in my current base, but this will be a decent test to do. So each of these tests, the way they're going to be done is I'm going to move my character to a portion of the screen where there are no animations and far enough away where nothing can see it. So to make this pretty obvious, I'm going to put a little indicator so that I know every single time that I need to come back here for this. So we're going to have this nice little spot there, or let's make it red so that I know where to come back. And I'm going to be looking at this the whole time. I'm going to run it at 100 speed like this. I'm going to go turn off any other potential items that I have other than just showing the entity time. Okay. So now the idea is we're going to run this at 100x speed until the point where this has been simulated for running for an hour. And then at that, just to eliminate any potential buffers or anything like that that exists. And we will look at the top FPS number. And we will do the same thing for looking at a snapshot of highs, lows for entities total. And for this, what I'm going to do is I'm going to go ahead and save this. And then I'm going to turn autosave off just so that that doesn't interfere with anything at all. And we're back. So what we're doing right now is I decided instead of running for an hour, 30 minutes is probably fine. So we're seeing this. The sleep time is completely zero, running as fast as possible. We are looking at absolutely the max. I'll just zoom in as far as I possibly can. So we're zoomed in here and we're watching this, and this has been producing solid production. This is just to watch that we are consistently making the items that we need and there are no stutters or stops with the science itself. So that's in a good spot. So right now looking at this, we're seeing somewhere roughly in the 1150, 1160 updates per second. I'm not seeing any huge dips on the original design. So that's good. So what I'm going to do now is I am going to take a screenshot of this, and I'm realizing that probably the thing that I don't want is I'd like a nice background for the screenshots. Red is profusely ugly, so let's do something that is like black refined concrete. Yeah, that's perfect. That's enough. And for my marker so that I know where to go back to, I'm going to make a surface of some sort. Let's just do lava. Why not? That's fun. So, gives me some volcanist vibes. I'm liking it. All right, perfect. So looking at this again, we're looking at about 1150, 1130. Seems pretty stable in terms of UPS utilization, which is great. Next up is the Silo V2. So it has the Silo modules in it. I'm already noticing now that the amount of space this is occupying is already significantly less compared to the last one, which is just nice having smaller sizes. But as per usual, we're gonna go to our hole and we're gonna wait, kick it up to speed 100, and well, I gotta get over there first. Let's go move our character model, that's more important. So we'll move over there, we'll kick it off, go to speed 100, and we'll be back after the test concludes. Alright, we have now just hit the 30-minute mark, so we're going to go ahead and see that we have the same production as before. So, which is good. I'm noticing a little bit more variance in terms of production, but that's, I guess, to be expected here. So, with these designs, we are oscillating a little bit more because they're belt driven, so that is one slight difference. Or not belt driven, there's just less assembly components, so they'll be active for longer, so less furnaces, those kinds of things. So looking at this right now, we are averaging already a higher number just right off the bat. That's pretty obvious. So we're now hovering at, where before we were at 1100 something, we're now consistently in the 12, almost sometimes getting close to 1300, which is, there you go, hitting 1300. We never hit that before, so that's already a very obvious UPS improvement over the last design that's still using the silo design. If that's better or worse, we'll find out in a second. So I'm gonna take a note of is that this is on average somewhere between 1200 and 1300. So that's just better, and we'll record the results and go from there. Last but certainly not least, we now have the non-rocket siloed version running here, all 16 of them, using belts to feed the walls, assemblers, and again, just like before, we go to our hole, do our test, and we'll be back after the results are completed. Alright, and we're back. We just hit about the 30-minute mark simulated. Production's again the same. Looking at these spikes, the production values have been exactly the same over the course of these tests. So where are we at now? So again, this is the belt-fed version. Looks like we are now hovering kind of a little bit closer to the V1 build in terms of we have now about 1100, occasionally just peaking over 1200 updates per second total. So we'll dive into further analysis on the entities and the update values and their highs and lows here. So I've gone ahead and broken down the data here for us. So for each of these categories here, we have the V1, V2 silo, and V2 belts from each of the tests after the 30-minute mark. We took a screenshot of each, and we've included all the entities and the game update as a whole. So instead of going through and trying to look at this pretty pixelated image and go through it, I've taken the time to break down them into these game statistics. So we're going to zoom in here a little bit and talk through it. So what I have here is the max UPS, update averages, mins, max for the whole game, and entity updates as well down here. So I've done already an analysis and broken this down. Here's an overall view of it if you're interested in the specific stats that we pulled from it. Again, this is just a snapshot, so an actual benchmark would be better, but this is kind of what I do to kind of quickly get an idea if I'm going to use a new design or not. So the V2 silo, this is just a single snapshot in time, so I wouldn't pay too much mind into this, but overall, we did see that the fluctuations in general, the V2 silo was the only one that actually got into the 1300 updates per second. So just looking at these three, if you just looked at this, the V2 silo is the most efficient overall in terms of game speed, but and actually getting about 100 updates more per second that it could handle compared to the original design we had, with a slight improvement, maybe 40 or so, 38 it looks like, compared to the V2 belts, or 42 rather, updates more that it could do. So again, this is just an overall metric to kind of guess the overall performance, if it's better or not, but it's a good insight. So control behaviors, there's not enough of a difference. This is 1 nanosecond difference between these two, and the V2 silo is slightly higher, so V2 belts wins out by a tiny margin, but this is, we're talking about 7 nanoseconds here. Seems like noise at this point. I don't think that we really can draw too much of a conclusion from this. So assembly machines, what was interesting is that the V1 had the most balance on it in terms of min max, so standard deviation was pretty low. But the V2 with belts had the highest maximum, and that was kind of what we're seeing. Is I think there's higher spikes whenever the inserters are pulling things actively off the belt. Not quite sure on that. That's my hunch, but just kind of looking at this. The V2 silo, though, interesting, was the most volatile, so the highest standard deviation. It had the best min time, but also the highest maximum time. So, on average, though, I'm guessing that the V2 silo is going to be a little bit more optimized, unless, again, that max time is a consistent problem, which we didn't see because those spikes seem to be a non-issue because of the overall high value that we had here. Again, just looking back at this, these statistics here, and this is where I'm talking about that being the most volatile. This had the V2 belts, even though the V2, so the V2 style had the lowest min and the highest, or almost highest max. So it's a pretty huge range there, but that average still wins out just by, again, like 1 nanosecond compared to the V2 belt. So not much in terms of average, but this variability was an interesting stat. Next, let's go into furnaces. They're all about the same. It kind of makes sense, I guess, because they're going to only hopefully run to meet demand downstream. And even though there were more furnaces in the V1 design, for sure, compared to the V2, and the V2 silo had slightly more furnaces than the V1, or the V2 with belts, by having 2 extra furnaces, but again, it had the highest max, but I'm saying that basically the averages were about the same, so there wasn't a huge difference on furnace overall improvement. Just having less entities is good. It's going to reduce your electrical network consumption over time when because your electrical network is based on how many entities are in the system, and the more and more things it needs to calculate on their current power consumption. So having less entities is always good, always going to optimize for that before doing any other analysis. Inserters, this is the bigger one where the V2 was the clear superior performer on this. It had the lowest average and basically had a pretty controlled maximum. The V2 belts had the highest max by far, so that's kind of a red flag for me. And then basically the V1 had a higher average than the V2 silo, and it was about equal to V2 belts, but had a slightly lower max. So that being said, the V2, what was interesting in this is that even though, surprisingly, the V2 silo has more inserters than the V2 belts, it wound up performing better, and I'm thinking this is, again, kind of a case where, like, really the only difference there was using silo chesting. So that's an interesting thing, that inserter time was overall reduced on the silo build versus the belts. So this is, again, just kind of a conclusion where I'm thinking there's probably some use cases for still doing silo chesting for things that aren't just on Fulgora. So overall conclusions, the V2 silo is the fastest update rate. V2 belts by 1 nanosecond. This is noise. We're going to ignore that. The assembly machines, the V2 silo was the most efficient, but just by a little bit. So not a big change there. So really, these 3 categories are really more of a tie. The inserters, the V2 silo was definitely the best balance of average and max time, and even though it didn't have the lowest min, the average and max is kind of going to give us a little bit better indicator of this is a better build or not. So for that reason, V2 stands out. It's the better one. V2 belts was pretty close behind, and V1 was definitely the least performant across the board. So We've definitely made an improvement with both of these designs. I'm going to be using the V2 silo to go into the Megabase, and that will be the attachment of the blueprint in the description below. So what you're seeing down here is the final end product that we have worked so hard on for this video. If you're interested in more videos like this, please let me know and give me some feedback in the comment section below. The point of this video was to kind of show a little bit of my design philosophy, how I go about creating and improving on designs, UPS testing, the whole shebang. This was a good opportunity for me to dive a little bit more deeper into some of the designs that has been seen in the Megabase video itself. If this kind of content is interesting, please let me know in the comments below. I'm trying out some different things as I really don't know what to make on YouTube. I am really enjoying sharing my designs with people, and just frankly the amount of comments that I've gotten and feedback that I've gotten from people from the first video that I uploaded has just been really wholesome and wonderful to see. So I appreciate everyone, especially I've just been overwhelmed by the response and the number of people that have subscribed. I'm going to try to figure out kind of what I want to do with this channel. I'm still not quite sure. I know one video that I have promised to make is the 600% Death World run, so subscribe if you're interested in that. I'll be creating that at some point. This is also a trial run for me to learn a little bit about editing, so follow along with me as I stumble along and try to figure that out myself. I am new to content creation and in general just editing videos. I'm a Factorio player at heart, and so I normally am a consumer of Reddit and post things there, and I'm trying this out to see if this is interesting for people and they want to continue to see more of these. So let me know in the comments below what your thoughts are on the video. Any feedback at all, I would really appreciate it. And thank you again for watching. My name is abucknasty, and I'll see you in the next video.